I had a couple people, Anthony and DJ, try to schedule appointments yesterday. It, for whatever reason, didn't work out. But for anybody who's trying to schedule an appointment going forward, please make sure that you know how to connect to the meeting. Either
oh yeah, Mr. Red,
or you are going to join the Google Meet.
Mr. Red, that was my fault. I had another meeting I didn't realize I had another meeting. That was my fault.
Okay, no problem. I just wanted to make sure you and everybody else knows how to join the call.
Yeah.
Was I supposed to meet you like in Google Meet? Because I was like here in Google Meet for like 10 minutes. So I just left.
Yeah, so it's another Google Meet. It's not this one. It's the one for it's one for my appointments. Which you gotta. I know that was probably a little confusing because you did check the option for Google Meet, but there was a link there that was different than our normal meeting. So don't worry about it. I just want to make sure you know how to do it going forward. I'll send the link to the chat now.
All right.
Okay. So today is not November 19th. Yesterday was November 19th, but we took that day as a work day, and I'm proud of everybody for being pretty productive yesterday. I know some of you still have a long way to go to get totally caught up, but we made some good progress yesterday. So let's just keep that momentum. We're going to have a 5-day weekend next week, and that's going to be a great opportunity for you all to make some progress. Obviously, I want you to enjoy family time if you have an opportunity to do that safely next weekend, and I also want you to rejuvenate and relax. But for some of you, we do have some catching up to do. All right, so some of those 5 days need to be used doing that catching up. But we made good progress. I want to establish that momentum and explicitly say that I'm proud of some of you who have caught up. I'm going to be catching up with my grading now that I've got some older work to put in. And I do also want to remind some of you that there is a Unit 7 test to take. So if you look in Power School and your grade is really low, it's probably because you didn't take the Unit 7 test, and that is a 100-point formal grade. So that has big potential to hurt your grade. So contact me if you know that is your situation. Today's lesson, the first part will be about ecosystems and human activities. This is from the first day of our 9th unit. The objective for this lesson is to infer how human activities may impact the environment. We also want to think about a word, anthropogenic. That word means caused by humans. Anthro means human, genic means caused or to spawn something. So these problems are human caused. And we also want to think about how humans have negatively impacted the earth. So there won't be too many notes to take today, but I do want to make sure you all have your notebooks out per usual so that you can refer back to the information that we're learning in today's lesson. So often when we think about humans' impact, we have to think about the ecosystem. And an ecosystem is a community made up of interacting biotic and abiotic factors. A community made up of interacting biotic and abiotic factors. What does the word biotic mean?
Living.
Thank you, DeMarco. That's correct. Sorry, it went down the wrong way. What about abiotic? What does that mean?
Non-living.
Excellent. So an ecosystem is a community of interacting biotic, so living things, and abiotic, non-living things. So we've got a list of things here. Some of them are biotic, some of them are abiotic, but I want you all to tell me what you think. What about soil? Would that be considered biotic? Okay, here we've got one person saying abiotic. That is correct. So even though we think about soil as having all these living things in it, If I were to put my hands in the soil and scoop some up, I might have some living things there. Soil itself is really just a combination of sand and rocks and what's called silt. What about elephants?
Biotic.
Biotic. Yep. Good. What about air?
Abiotic.
Good. Carbon.
Abiotic.
Abiotic. Good. Carbon is just an element. It's not living. What about trees?
Biotic.
Biotic.
Trees are living. Yes. What about
Abiotic.
sunlight? Abiotic.
Biotic.
Biotic.
Bacteria are biotic.
Abiotic.
Good. Good. Excellent. Viruses are abiotic. What about grass?
Biotic.
Biotic. And biotic.
Excellent.
Okay.
So sometimes that bacteria and virus juxtaposition can be confusing. We don't know sometimes if viruses are living or non-living. Scientists typically consider them abiotic because they cannot reproduce on their own. All right. So there's not necessarily anything to write down here. Maybe you might want to write the first sentence either in English or in Espanol. But there are many types of ecosystems. And ecosystems can be as large as a continent or as small as a pond. An ecosystem might even be inside of your intestines. So an ecosystem is really just a place where living things are interacting with non-living things, typically living things from different species. The abiotic factors that we know to be playing a large role in ecosystems and the type of life that exists in ecosystems include rainfall, temperature, humidity, soil quality, air quality, altitude, and a number of other things that we can measure. But we know all of these things are non-living, but they also play a role in the way that the living things interact with one another and the way that the living things are able to survive and reproduce. I like this map. This is an interesting map. It shows not necessarily ecosystems, but it shows terrestrial biomes. Terrestrial is a word that means on land. So obviously water is its own biome and 70% of the earth is covered by water. But and different places, different types of water obviously have different types of ecosystems as well. But this map is just thinking about the terrestrial ecosystems or biomes. We can see all these different biomes exist in different parts around the world, but you've got some similarities. For example, tropical evergreen forests, which is basically a rainforest. We've got rainforests in Central America and in Brazil with the Amazon rainforest, but also in Western Africa, in what is basically the Democratic Republic of the Congo, the Central African Republic, Ghana, even in Kenya, there's a tropical evergreen forest. We've got Thailand and Laos and Vietnam and Indonesia. They have tropical forests. The southern tip of India and Sri Lanka. Madagascar has a forest. So all these different places have similar terrestrial biomes, but we think of them as being very different places. We can also see that deserts, this pink color, covers a good amount of the earth. Northern Africa with the Sahara Desert, but even in Chile, which is in South America, there's the Atacama Desert. And then we can also think about the Middle East and what is Pakistan and Tajikistan, Turkmenistan. They also have some desert ecosystems as well. So I like this map. It really shows some of the ecological similarities across the earth. And we can also even see that a large portion of the northern part of the earth is covered in ice. But then also in the southern tip of Argentina, there's also ice there, tundra as well. Okay. So question, what is the relationship between biotic and abiotic factors in an ecosystem? Which one depends on which?
Biotic depends on abiotic
Okay, why do you say that, DeMarco?
because things like water, we humans need water, and water is abiotic, and we're biotic.
Good, yeah. So the water would obviously be here even if there was no life left on Earth. The water would still be here. So we depend on water because if all the water was gone, we'd be in a really dire predicament. But there is some interaction between these two things. For example, these plants require water for life, but when that plant dies, it will eventually be returned to the soil. It will disintegrate and it will begin to decompose. And the carbon and the hydrogen and the oxygen that once made up this plant is eventually going to return as nutrients into the soil. Okay, so although yes, biotic factors do depend on abiotic factors for survival, it's also true that biotic factors influence their environments as well. So typically when we're talking about ecosystems, we organize them in these 5 levels. First is organismic level. An organism is just an individual animal, plant, or unicellular life form. So that could be a human being, that could be a bird, that could be a bacterium, that could be a plant. Then we move up to a population. A population is multiple organisms from the same species living within a given area, living together as a group. Might be a school of fish, it could be a flock of birds, it could be a neighborhood of human beings, it could be a colony of bacteria. As long as they're the same species living in a group together, they are a population. A community is multiple populations that live together in a defined area. So this is probably going to encompass quite a number of species. Even living where we live in Charlotte, we live amongst other species of insects, of birds. You might see a possum or a raccoon sometimes. You might see some lizards. We've got other species living around us. Then the way that those species, those living species, interact with their environment defines an ecosystem, as we already talked about. And lastly, the biosphere. So this is the part of the Earth that contains all of the ecosystems. All right, so I didn't set up the Padlet, so don't worry about that. We're just gonna watch this video. It's gonna talk about the human impact that we've had on the Earth and why it's urgent that we do something about that impact.
Fun fact, planet Earth is 4.5 billion years old. Mankind, about 140,000 years old. Let me put that in perspective. If you condense the Earth's lifespan into 24 hours, that's 1 full day, then we have been here on this planet for, drum roll please, 3 seconds. 3 seconds. And look what we've done. We have modestly named ourselves Homo sapiens, meaning wise man. But is man really so wise? Smart, yes, and it's good to be smart, but not too smart for your own good. Yes, we have split the atom. Yes, we build clever machines that navigate the universe in search of new homes, but at the same time, those atoms we split created nuclear warfare. In our quest to explore the galaxy, rejects and neglects the home that we have here now, so no, that cannot be wisdom. Wisdom is different. While intelligence speaks, wisdom listens, and we willingly covered our ears to Mother Nature's screams and closed our eyes to all of her help-wanted signs. Wisdom knows that every action has an equal and opposite reaction, so if we were wise, we would not be shocked when we see storms that are stronger than ever before, or more drought, hurricanes, and wildfire than ever before, because there's more pollution than ever before, more carbon, more trees cut down than ever before. At a record pace, we have increased the extinction of animals by 1,000 times the normal rate. What a feat. In the next 10 to 100 years, every beloved animal character in every children's book is predicted to go extinct. Lions gone, rhinos gone, tiger, gorilla, elephant, polar bear gone. In 3 seconds. Species that have been here longer than us will be gone because of us. In this 3 seconds. In an existence shorter than a Vine video, we turn the circle of life into our own personal conveyor belt. Somebody, anybody help. We were given so much, the only planet in this solar system with life. I mean, we are 1 in a million. No, actually, scientifically, we are 1 in a billion, trillion. That's the 1 followed by 33 zeros. And I don't want to get too spiritual, but how are we not a miracle? We are perfectly positioned to the sun so we don't burn, but not too distant so we don't turn to ice. Goldilocks said it best, we are just right. This paradise where we are given medicine from trees, not coincidentally, but because like the song says, we are family. Literally everything, every species is connected genetically, from the sunflower to the sunfish. And this is what we must recognize before it's too late, because the real crisis is not global warming, environmental destruction, or animal agriculture. It is us. These problems are symptoms of us, byproducts of us, our inner reflection. Loss of connection has created this misdirection. We have forgotten that everything contributes to the perfection of Mother Nature. Corporations keep us unaware and disconnected, but they have underestimated our strength. Contrary to popular belief, millions are waking up out of their sleep, seeing our home being taken right up under our feet. We cannot allow our history to be written by the wicked, greedy, and loony. It is our duty to protect Mother Nature from those who refuse to see her beauty. Call me crazy, but I believe we should have the right to eat food that's safe with ingredients we can pronounce. Drink water that is clean, marvel at trees, breathe air free of toxins. These are natural rights, not things that can be bargained for in Congress. See, they want you to feel powerless, but it has been said that something as small as the flutter of a butterfly's wing can cause a typhoon halfway around the world. But when enough people come together, we too will make waves and watch the world into a new era filled with love and connection, freedom for all without oppression. But it is up to you, yes, you watching this behind this screen, to make the effort, because time is of the essence, and only together can we make it to the 4th second.
So it's a pretty poignant video.
Planet Earth is
There's a lot of good stuff
4.5
in that
billion
video.
years old.
Let's try to analyze further some of the human impact that we've had. So we've got an image here of an interstate highway system. I don't know exactly where this is or how old it is, but what do you all think the human impact on the environment is because of this interstate highway system?
Our impact on it.
So let me ask you
Problem?
another way. Based on how we built this, what do you think the impact on the environment was?
Oh, we had to cut down trees.
We definitely had to cut down some trees and remove grass and level off the terrain. Anything else that we want to point out? Thank you, DeMarco. Well, I mean, even just by having to cut something down, having to cut trees down, we are, little by little, okay. Yeah, certainly, that's what I was getting at. When you cut trees down, you are cutting down habitats. Trees are not only living themselves, but they are also homes for plenty of other species. So removing trees is habitat removal. All right, so as we've increased our infrastructure and built huge 5-lane highways all across our country and all across the world, we've certainly eradicated a lot of habitat. Okay. What about this? The Great Garbage Patch. What's the impact here? This is real too.
It's polluted.
Yeah, species in the water. It we I don't know how to say it, but we're killing species in the water.
It's
Yeah.
polluted.
Good. Yeah. So we're polluting the oceans
That's what I meant to say.
with garbage, and it's certainly, like DeMarco said, it's killing species, marine species, species of fish and other organisms that live in the ocean. What happens is that because of the ocean currents, all of the garbage that might be dumped in only one small place, it all gets, or in several small places, it all gets swept into one big patch in the middle of the Pacific Ocean. And the problem with this is that, you would think it would be pretty easy to just come through with a net and just catch as much of this garbage and remove it from the water. But the problem is that after it gets exposed to water, after it's exposed to sunlight, and waves are crashing down on it, and birds and animals are picking at it, it starts to disintegrate. It breaks apart. And so it becomes so small eventually that not only can we not catch it with the net, but animals start to, absorb those things. They absorb the plastic, they eat it, they breathe it in. And so it's very, very damaging to them. Not only that, but once we catch those fish to eat the fish, now we're eating that same garbage as well. So this is a big problem, and the solutions are not easy. One of my students in my last class asked, why can't we just put our garbage in space? I have actually seen that people are considering that as an innovation, a potential innovation, but that also comes with challenges. First of all, getting to space is not easy. It's not like we just, we just easily just throw it up into space. That's not an easy thing to do. Getting out of the Earth's orbit, or not out of the Earth's orbit, but out of the Earth's atmosphere into space takes a lot of energy and coordination. So doing that solely with the plan of dumping garbage would not be easy. What about this? Do you guys see or think that there is any human impact here with these brightly colored, cloudy skies?
Yes, don't that come from airplanes?
Okay, so yeah, airplanes definitely, they can pollute the skies. Good point. Anything else?
Like I'm trying to say it, like pollutants in the air, like from chemical places and stuff.
Good. So factories and refineries, they definitely are polluting, and sometimes you would see such great pollution that it might appear to be a cloud in the sky, and it's actually not a natural cloud, it's a chemical cloud. So we don't know what this image specifically is. It might just be a really pretty sunset, and on a cloudy day, but it could also be the result of pollution, whether it's from airplanes or factories or cars, or just a buildup of smog over some urban area. We really don't know what this could be. What about this? Do you think that this could have been caused by humans? I don't know which country this is, but it's somewhere in Southeast Asia. Does anybody think that there's some human impact here?
Well, it's flooding, and they outside, so I'm guessing they ain't got nowhere to go or something happened to their home.
Yeah, floods are definitely made worse by urbanization. So as we build up buildings and as we lay down concrete doesn't absorb water in the same way that soil does. So, in the past, when human civilizations didn't pave their streets with concrete, even if it did flood, the flood would basically recede much more quickly and much easier, because it would just be absorbed by the soil. It would be absorbed by the plants. But now we've layered concrete over vast portions of the country, and it just allows water to just linger and just sit there. And water that is stagnant, water that's not moving, can become a huge biohazard as well. So it's not good to, try to walk through floods because you don't know if there's a current. You also don't know what's in the water. But yeah, that's definitely can be seen as caused by humans. What about this? What's the human impact of this?
The impact is that the organisms that live out there, they won't have a home or they'll die out.
Yeah, and Jessica, I love what you said. Yeah, what we're seeing is another form of habitat destruction, which is what you're talking about, DeMarco. But Jessica also said global warming, and she's 100% right about that. We're going to talk more about that. But the planet is getting hotter, and it's for these polar bears and other animals that live either very far north or very far south on our planet. The ice is melting, and it's making it much harder for them to find a consistent home. It also makes eating harder because they need to have some access to the water via ice. Hurricanes. This really is tied into what Jessica said as well, global warming. But we can see that. Look at the massive size of this hurricane. The eye itself is basically the size of southern Florida. The entire hurricane itself is much larger than the state of Florida. We can see that this hurricane probably devastated Cuba, probably devastated Haiti and Jamaica. It probably devastated Puerto Rico, which is right here. You can even hardly even see that. And it probably also had some impact on Charlotte, which is up here somewhere, definitely on the coast of North Carolina. So these hurricanes are not only happening more often, but they're also becoming much more damaging. They're becoming much more severe hurricanes. They're getting bigger. The wind speed is increasing. The amount of rain that falls is increasing. And it is ultimately because of global warming. We're going to talk about the ways that humans have impacted the environment in these upcoming slides. I do want you all to take some notes on this because it will be tied into your asynchronous assignment from this lesson. But make sure you do have your notebook out. The first thing we're going to talk briefly about is population growth. So the problem with population growth is that the number of people on Earth has increased exponentially over the last 150 years since the Industrial Revolution. So we're going to graphs and images that is going to demonstrate how this growth has taken place and where it has taken place. But the consequences of this population growth is that more land and animals are needed to feed huge numbers of people. And most of the growth is taking place in poorer countries. So we need more land and animals to feed poor people who really can't afford to pay for it themselves. There's also going to be, and already is, a shortage of drinkable water. So even though Earth is covered by water, 70% of the Earth's surface is covered by water, most of it is not drinkable. Most of it is salt water. And so it will be damaging and unhealthy for a person to drink that. So we've got to find other sources. Either we have to purify that salt water and desalinify it, basically take the salt out, or we've got to have fresh water that we can drink. But that is a privilege in most places. And we also have to continue to destroy habitats in order to make space for all of these people. All right, so population growth is a problem and has very clear consequences. The reason this population growth is happening is because the world is and has been industrializing. It's been developing. And we can study this development really in 5 stages. In the first stage, there are a lot of people being born because in the first stage of a country's development, They are not very industrialized. They're not developed. They're not urban. So most of the people in the country are living on farms. They're living in rural environments. What this means is that a lot of people are having a lot of kids because, number one, they might expect, unfortunately, 1 or 2 children to die before they reach a mature age. Number two, they need to have a lot of kids to help them farm. They're feeding themselves based on their own animals, their own produce. So they have to grow that produce. They have to tend to those animals. So you need a lot of people to do that. So it benefits you to have 6, 7, 8 kids. Additionally, the death rate is high because they don't have the medicine, they don't have the infrastructure. Countries in this first stage of development are typically struggling with something as basic as hygiene. So people might be drinking from the same water source that their waste is going into, which is extremely dangerous and can lead to a number of diseases that are, obviously very unhealthy. So even though people are having a lot of kids, a lot of people are dying as well, and they might be dying before they get to the age where they can have kids. So the lifespan is pretty low. So what this means is that you're having a lot of babies, but people are also dying at high rates. The population is not very high. This is where the Earth was for the majority of human history. People lived in pretty small civilizations relative to where we are now. Some of the largest cities, 2,000, 3,000 years ago, were made up of only 1 million people. Today, Charlotte is the 17th largest city in the United States and has almost 1 million people. And on the world stage, it really doesn't even make the top 50. Okay, but a country like this in stage 1, we might think of today as being Rwanda, a country in Central Africa that has dealt with civil wars and has not industrialized much. Stage 2 takes place when people are still having a lot of kids, but the death rate is falling because the country is getting richer. Medicine is improving. Hygiene is improving. Sanitation is improving. People have access to more water, better food. People have access to medicines. So what happens is that the death rate falls, the lifespan increases dramatically. So instead of the lifespan being 38, now the lifespan might be 68. People are living longer, but they're still having a lot of kids. So what happens is that the population skyrockets. Not as many people are dying, but a lot of people are being born. Anthony, question?
Oh yeah, like in the past, back in the Adam and Eve days, people used to live a lot longer. What was that for?
That's a kind of a different conversation. That's kind of based on religious beliefs, and yeah, I'm not sure that I'd be equipped to have that conversation right now. But that's a good question, though.
I see. All right.
So stage 2 country we might think of today as being, let's say Ghana, a country that is industrializing and medicine is improving, but people are still having a lot of kids, so their population is increasing dramatically. In stage 3, the birth rate starts to fall. The reason this happens, we can even look in the United States and think about it. A lot of people in the North, a lot of Black people, people of color, their roots are in the South for pretty obvious reasons. If you go back far enough, their ancestors were likely slaves. But then after the Civil War and then after the Reconstruction period, people started to move north in what we know today as the Great Migration. They were looking for jobs. And so they moved instead of living on farms in the South, they moved into cities in the North, like Chicago, Detroit, New York. They also went west to Houston and Dallas and LA. And so they moved to these urban areas, which means that in an urban area, there's not as much space. And it's also expensive to have a lot of kids. You got to have money to feed all of those mouths. And you might also be living in a small apartment. So it doesn't make sense to have 8 kids. People start having fewer and fewer children at that point. So the birth rate falls, the death rate is still pretty low. So the population is growing, but it's not growing nearly as fast as it did in stage 2. A country in stage 3 we might think of today as being Thailand or Vietnam. These are countries that have already industrialized, and now people who have been living on farms are starting to see the fruits of that industrialization. A stage 4 country is the United States, where you've got a low birth rate, you've got a low death rate, which means that the population really isn't growing that much. Population here in the United States is growing, but not as much as it once did. And then a stage 5 country, basically you might even see fewer people being born than people dying. So this might be a country like Italy or Japan, where the population is actually shrinking. On average, though, yesterday there were about 220,000 across the entire world, 220,000 more people who were born than who died. So think about that. Yesterday alone, the global population added 220,000 people. And that's been the case every day this year, which means that this year, the population has grown by about 72 million people on the earth. So population is still growing very quickly. We can see that here. Population is still growing, and it's expected to continue to grow until about 2100, the year 2100. Maybe some of us will still be around. You all will be you'll be in your 90s. So there's a good chance some of you will still be around at that point. But the population is expected to peak at that point at around 11 billion people. Right now, we're almost at 8 billion. So we still have about 3 billion people to add, which is a little, that's a little disconcerting.
That's right. I'll be right back. I gotta use the bathroom.
Okay. Most of the growth, as we can see, is happening in the two most populous continents, Africa and Asia. The problem with that is that a lot of people in those continents are living in extreme poverty. Extreme poverty is not something that we would even really associate with the United States, because we have people who are living in poverty here, but extreme poverty is characterized by people who make less than $1 a day. So imagine trying to feed yourself and a family on less than $1 a day. You just simply couldn't do it. So this is a problem, because these countries are increasing dramatically in terms of their population size, but most of the population growth is happening in poorer communities, people who need basically to be, unfortunately, taken care of because they can't afford to live any other way. If we look down here, Europe, North America, and South America, Europe's population is actually decreasing. And North America and South America, they're both increasing, but not nearly as quickly as Africa and Asia. We can see that the two most populous countries, China and India, are both in Asia, and they both have over 1 billion people. China has about 1.45 billion, and India has about 1.38 billion people. Huge numbers of people. We can see that the United States is in 3rd place. We've got about 350 million people, but our population increase is slowing. We're eventually going to be caught by Nigeria and Indonesia. They're going to surpass us, which means that the United States will probably be in about 5th place in the next 50 years or so in terms of how big our country is. But if we go back to the 1800s, we can see that China was still the biggest country, but they were about where the United States is right now, at about 350 million. And the United States was at less than 100 million people in the 1800s. Another way that humans are impacting the environment is pollution. So as the globe industrializes and develops, we have to do all this manufacturing, all this shipping, all this transportation. So harmful substances are introduced into the environment. And when we say the environment, we're not just talking about the air. We're not just talking about the atmosphere. We also are talking about the water and the soil. The consequences of that: water sources become poisoned and therefore are no longer drinkable for human beings and other mammals. But for the marine animals, the fish, they also can't live there safely. Organisms are becoming more exposed to carcinogens, which cause cancer. And bird migration patterns can also be disrupted, as we're going to see in a couple slides. So pollution is also a big problem. I'm not exactly sure where this is, but we can see that this is some type of factory or some type of refinery. So how many of you knew that the gas that you pump into your car is not the same thing that came out of the ground? We're going to talk more about that. But it has to go through these refineries. And as a result, we can see all of this. Some of this is water vapor, which is harmless, but some of it is also carbon dioxide and methane and chlorofluorocarbons, which are really bad for the atmosphere. We can see chemicals being pumped into water sources, which is also obviously really, really dangerous. And then something even that we might think of as positive, like a wind turbine. Wind turbines produce renewable energy. They can create energy from the wind. Obviously, the wind is not going anywhere. As long as there are oceans, there will be wind. So it's what we consider renewable. We think that that's a good thing, right? It's better than fossil fuels. It's healthier for the earth. And that's largely true, but we also have to acknowledge that wind turbines disrupt bird migrations. And in fact, they kill many birds every year, as the birds have not yet adapted to these gigantic wind turbines that move, being in their way as they're moving from north to south every year. So this is a different kind of pollution. This is what we would consider space pollution or sound or noise pollution, but it's also equally harmful. Climate change is another problem. It's the third of our 7 problems. As a result of human activities and widespread shifts in weather patterns, Earth is getting hotter. This is a result of the greenhouse effect, which traps heat on Earth. But as we add more and more carbon to the atmosphere, more and more heat is trapped on the Earth, and it's warming the planet dramatically over the last 100 years. The consequences of this is that aquatic animals either die or they're forced to migrate to cooler waters. We're seeing weather events become much more common and more devastating. And we're also seeing glaciers that have existed for 20,000 years melt. And because of that, sea levels are going to rise. So places like Miami, places like New Orleans, places like Asheboro in North Carolina and Wilmington, these places are going to be threatened because they are on the coast. And as the sea levels rise, it might eventually overtake those cities in a worst case scenario. So we can see global warming affecting marine and aquatic species like coral. These are really what we consider like the canary in the coal mine, meaning they are the first signs that something is going really, really wrong. So we've been watching these coral, which are actually animals, even though they look like plants, these are actually animals. What's happening is that these coral are being bleached. So we can see them literally turning white, and that means that they are dying. They're dying because the water temperatures are so high that these corals simply can't survive. And it's also a result of the water temperature rising, which means that it's becoming more acidic, which is bleaching these coral. Unfortunately, scientists are now predicting that the coral that are in the Great Barrier Reef, which is right off the coast of Australia, they are permanently damaged, and some of them are permanently dead. So if you have a chance in the next 10 years, when you guys are in your 20s, I would definitely encourage you to make a trip to Australia so you can see these coral, because chances are they won't exist for our children to see. We can also see that fish species have to migrate as a result of water temperatures rising. So these 3 species of fish, the American lobster, the red hake, and the black sea bass, they have to move further and further north to exist in waters that are their ideal cool temperatures. So this black sea bass that we once used to be able to fish it right off the coast of Virginia. Now we have to go up to New Jersey and New York to fish for these black sea bass. The red hake, which we once used to find on Long Island, right off the coast of New York, now we've got to go all the way up into Maine to find the red hake. The American lobster, which we used to again be able to find in Rhode Island and in Connecticut, now we've got to go up into Vermont to fish for these American lobsters as they're moving further and further north to find colder waters. So this is a good animation because it shows that the number of natural catastrophes across the globe is increasing, but it's not all natural catastrophes. The geophysical disasters, those that are caused by shifts in the tectonic plates that are just under the surface of the earth, like earthquakes, tsunamis, and volcanic eruptions, the number of those events is not increasing. Every year it's at about 50 of those events, give or take 10. But the number of events that are caused by weather, hurricanes, tropical storms, floods, extreme temperature droughts, and forest fires, those types of disease are increasing dramatically. Not diseases, of disasters are increasing dramatically. So this is yet another sign that global warming is having an impact. But it's not just that the number of natural catastrophes is increasing. Oops. Oh no, sorry. Keep that in mind. It's not just that the number of natural catastrophes is increasing, it's also that their severity is increasing. And if you look at the news at all, you'll remember that a couple of months ago, one of the biggest news stories were the wildfires in California and Oregon and Washington. These were some of the largest wildfires in the history of those states. All right, so we can see that the size, in 1985, there were about 3 million acres of forest that were burned by wildfires. In 2015, that number had risen to about 10 million. So the size of these catastrophes, their severity is increasing. They're creating a much more damage, not only to human property, but also we've got to think of these trees as living beings. And they also are living things that house other living things. So there are squirrels, there are fish, there are chipmunks that rely on these habitats. We can also see that global warming is causing the ice shelves to melt, the glaciers to recede. Let's look at this interesting video.
Glaciers have been shaping our world for millions of years. But as climate change warms the planet, glaciers are disappearing, not only altering the landscapes they leave behind, but changing our oceans, weather, and life on Earth as we know it. A glacier is a huge mass of ice that moves slowly over land. Glaciers can be classified into two general groups: alpine glaciers and ice sheets. Alpine glaciers form on mountainsides and move downward through valleys. Sometimes they create valleys by pushing dirt, soil, and other materials out of their way. These glaciers are found on every continent except Australia. Ice sheets, unlike alpine glaciers, are not limited to mountainous areas. They form broad domes and spread out from their centers in all directions. As ice sheets spread, they cover everything around them with a thick blanket of ice, including valleys, plains, and even entire mountains. The largest ice sheets are called continental glaciers. They cover vast areas, including most of Antarctica and the island of Greenland. Glaciers can form over years when more snow piles up than melts. Soon after falling, the snow begins to become denser and more tightly packed. When new snow falls and buries the previous year's snow, the bottom layer becomes even more compressed. The dense, grainy ice that has survived 1 year's melt cycle is called firn. When the ice grows thick enough, the firn grains fuse into a huge mass, called glacial ice. The glacier may begin to move under its own weight through a process called compression melting. As they move, glaciers erode or wear away the land beneath and around them. When glaciers began their latest retreat less than 20,000 years ago, they left behind many landscape features, such as lakes, valleys, and mountains. Glaciers provide people with many useful resources. Glacial till provides fertile soil for growing crops, and deposits of sand and gravel are used to make concrete and asphalt. Many rivers are fed by the melting ice of glaciers. The most important resource provided by glaciers is fresh water. Earth's average temperature has been increasing dramatically for more than a century. Glaciers can act as indicators of global warming and climate change in several ways. Melting ice sheets contribute to rising sea levels. As ice sheets in Antarctica and Greenland melt, they raise sea levels, adding fresh water to the ocean every day. The loss of glacial ice also reduces the amount of fresh water available for plants and animals on land. Large additions of fresh water change the ocean ecosystem as well as ocean currents. Additionally, less salt in the ocean could disturb the Gulf Stream, drastically changing the weather on land as well. Since glaciers are so sensitive to climate change, the increased speed of glacier melt is an early warning system for the rest of the planet. And if global warming goes unchecked, many, if not all alpine glaciers could disappear completely. Glaciers have been...
Okay. So another problem, burning fossil fuels. Fossil fuels like natural gas, coal, and oil are a non-renewable source of energy that can't be replaced. And the use of them contributes to global warming and pollution. These energy sources will eventually run out. Fossil fuels are called fossil fuels because they are created by dead organisms that died hundreds of thousands, millions of years ago. As those organisms died, that organic material was preserved. It got shrunk underground, essentially. It was pushed underground, and it got very tightly packed together under an immense amount of pressure, and it got heated up. And so it created these fossil fuels. We still have access to these fossil fuels via pipe systems and coal mines, but using these fossil fuels is not good for the environment, and eventually they will run out. Here's an example of one of those drills. This is an offshore drill. So this is off the coast of, who knows, this could be maybe in the Gulf Coast. But there are several drills. You can even see some of these black columns and over here as well, going deep down into below the surface of the water and deep down into the seabed, and drawing out the oil that's underground. Now, the oil that you all put in your car, as I said earlier, is not the same thing that comes out of the ground. The oil that you've put in your car has gone through a refinery process in which certain materials are taken out and certain chemicals are put in. Chemicals that help your engine to run safely, chemicals that help your engine to run for a longer period of time, chemicals that help your engine to run more efficiently. But all of that eventually is all of that in this refinery process pollutes the environment. Okay, so it releases carbon dioxide into the atmosphere, which contributes to global warming. Another type of fossil fuel extraction is called fracking, in which fluid is essentially blasted deep into the earth to create fractures in the earth, and then you can draw oil out or gas out of those fractions. The problem with that is it can contaminate water sources. Okay, so it's dangerous and it's also not good for the environment. Another problem that's caused by humans is invasive species. So as human beings and our businesses have spread all over the globe, we've often unintentionally brought a non-native species to a new environment. And that organism then dominates the new ecosystem. The problem with that is that the native wildlife that was always there might end up being decimated because we might introduce a new predator into the ecosystem, and so they get preyed upon, or we might introduce another source of competition for limited resources. Abiotic factors might also be depleted or altered as well. So invasive species are not a good thing. We have some invasive species in Charlotte that we'll talk about next time. But one example that we can think of in the United States is called Cajun grass. Cajun grass is an Asian plant that arrived in the southeastern United States from seeds that were in packing material. So this was totally unintentional. But now this Cajun grass is spreading uncontrollably through Georgia, Alabama, and Mississippi. So the southeastern United States. The problem is that the native wildlife like rabbits and deer, they don't like the Cajun grass. They're not eating it. It's not a part of their diet. So even though we might have expected, oh, this won't be a big deal, once the native wildlife get exposed to it, they'll just start to eat it like they always do. For whatever reason, they do not eat this type of grass. Also, Cajun grass is flammable. So it's increasing the likelihood of wildfires in the Southeast. So this is a big problem for the state governments of Georgia, Alabama, and Mississippi to think of. And this grass does have the potential to eventually spread maybe as far north as North Carolina. So it's something to think about. Another example, the European green crab somehow made its way all the way from the northwestern coast of Europe to the western coast of the United States in San Francisco. So huge amount of water covered, probably because of some type of ship, some type of boat that was moving from Europe to the United States. The problem with these crabs is that they are now out competing the native species for food and habitat. And in addition to that, they're also eating the shellfish that exist on the western coast of the United States. So it's having an ecological impact as well as an economic impact. Two more. Or actually, yeah, two more. Another problem, ozone depletion. So the ozone is the Earth's protective layer that shields us from the sun's harmful UV radiation. The ozone also traps heat on Earth. So that trapping of heat is a natural phenomenon. That's always been the case. The problem is that because of human activities, we've introduced what are called chlorofluorocarbons, or CFCs for short, as well as carbon dioxide into our upper atmosphere, and this is harming the ozone. One molecule of carbon dioxide can kill about 100,000 atoms of ozone, can destroy about 100,000 atoms of ozone. So that's a huge problem because we are pumping millions of tons of carbon dioxide every year into the atmosphere. And it's faster than the ozone can revive itself or replace itself. The consequences of that is that because the ozone is being depleted, UV radiation is causing skin cancers, and marine and plant species are also being damaged. This phenomenon of ozone depletion was actually discovered by a Mexican-American scientist named Mario J. Molina. In the 1980s, in 1989, they discovered that this ozone layer was being depleted and that there was a huge hole over the North Pole that had opened up in the ozone. The good news is that slowly but surely, changes are occurring and the hole is shrinking. So the ozone is replacing itself. It's getting a little better. Bioaccumulation, this is our last one. Bioaccumulation is the phenomenon in which over time contaminants like pesticides or heavy metals like mercury and iron, they end up in the ocean where marine ecosystems will start to absorb those chemicals. And these contaminants will build up in the bodies of those organisms. So it ends up poisoning some of the fish and other aquatic organisms. But also, as we move up the food chain, larger and more sophisticated animals, like mammals, like you and I, end up getting poisoned as well because we're eating those fish. So let's see that taking place. Let's say we've got a refinery, some type of factory that is polluting the air above it. That air is not just going to disappear. Eventually, it gets the rain will rain some of those chemicals back down, and those chemicals will eventually make their way to the ocean or to a lake. Once it reaches the open water, phytoplankton are going to absorb the chemicals. Phytoplankton are photosynthetic organisms that live in the ocean. They do photosynthesis and they're very, very small. They absorb the chemicals. Then, of course, other animals come along and eat those phytoplankton, like zooplankton, which are also pretty small, like shrimp. They come along and eat those phytoplankton, but they're eating a lot of phytoplankton. So they're now contaminated by a lot of those chemicals. Then another fish comes and eats those zooplankton, those shrimp, and they eat a lot of those shrimp. So now there's a lot of chemicals and even more in these larger fish. Then maybe another fish comes, like a salmon comes and eats that other fish. And eventually you just go on, and the larger the animal gets, the higher up the food chain you go, the more contaminant you have. So even humans, as we eat salmon and other fish, we might also be at risk of being contaminated by these chemicals. So this is a dangerous phenomenon. All right, so that was a long lesson. We didn't get to the second one. That's okay. We've only got 4 minutes. I do want you all to be aware of the fact that there is an asynchronous assignment from today's lesson, as well as an exit ticket. So you all can take the weekend to do those two things so you can stay on track. You might also take the weekend to get caught up with any assignments that you might be a little behind on. Of course, per usual, all of those assignments are on Canvas for you all to see. The assignment is pretty straightforward. It's just going to ask you to basically summarize those 7 problems that we just went over and talk about their consequences. I did make the slides available to you all, but you have to use your own words. I've been seeing a huge problem with plagiarism. People who are copying things from the internet. I definitely want you all to start getting in the habit of using your own words, because plagiarism is a serious academic violation. Okay, so you guys know where to find those assignments. You know how to do them. I will let you go a few minutes early today so you can have some extra time before 4th block. But I hope everybody has a good weekend.
Mr. Rudd.
Yes, sir.
I got a question. I was here on Wednesday, but you marked me absent.
Okay, I'm changing that now.
Have a good day, Mr. Rudd.
Thank you. You too.
I was a little late though, like 10 minutes late.
Okay.
All right, Mr. Roy, have a good day.
Thank you. You too.